Welcome to Topcast, Chapter 17, Unsustainable, from the Beginning of Infinity series. This is part 4 of that particular chapter, and it will be the last. We will get through to the end of the chapter today, possibly a little longer than the previous chapter, and next time I'll be back in my studio where I can do the final chapter called The Beginning. But for now, for a few parts now, we've been talking about the Easter Islanders. But let's read the final part about Easter Island, the culmination, if you like, of their civilization, their primitive civilization. David writes, "We do not know what horrors the Easter Island civilization perpetuated in the course of preventing progress. But apparently, its fall did not improve anything. Indeed, the fall of tyranny is never enough. The sustained creation of knowledge depends also on the presence of certain kinds of idea, particularly optimism, and an associated tradition of criticism. There would have to be social and political institutions that incorporated and protected such traditions, a society in which some degree of dissent and deviation from the norm was tolerated, and whose educational practices did not entirely extinguish creativity. None of that is trivially achieved. Western civilization is the current consequence of achieving it, which is why, as I said, it already has what it takes to avoid an Easter Island disaster. If it really is facing a crisis, it must be some other crisis. If it ever collapses, it will be in some other way, and if it needs to be saved, it will have to be by its own unique methods." Pause there, my reflection. Now, at the end of the last chapter, I was kind of riffing on the idea of civilization being this unfathomably complicated system that we know contains inexplicit knowledge. Okay, certainly our Western civilization contains inexplicit knowledge of how to maintain stability while undergoing great change. And we don't know all the reasons why this happens, why we're able to maintain peace and relative harmony, relatively good wealth creation, relatively fast knowledge creation. We're able to come up with vaccines and new technologies relatively quickly, certainly at a rate unprecedented throughout human history. But we don't know all the ways in which this happens. And I neglected to refer to David Deutsch's excellent analogy of this way of viewing a civilization with people being on a submarine. And he mentioned this in one of his podcasts with Sam Harris, and it's a wonderful analogy. And he basically said, look, people who want to upend Western civilization, who want to tinker with the long-standing institutions which maintain stability, they don't know what they're doing. It's basically like they are passengers on an extremely technologically advanced underwater nuclear-powered submarine, but they don't know that they're on a nuclear-powered submarine. Instead, they think they're on a yacht or some other kind of boat, and they want to open up all the hatches in order to get a better view. Okay, so that's the situation that we're kind of in. We are, all of us, passengers on this submarine, passengers on this amazingly sophisticated, complicated piece of societal level technology. Call it a civilization, call it Western civilization. And there are some people who just ignore the fact that it has taken a long time, lots of philosophers, leaders, scientists, people, a culture gradually evolving, gradually trying things out, finding out what doesn't work, and preserving those things that work and enable the civilization to remain stable over time. These traditions, especially these traditions of criticism, are so important and so underappreciated that many people think that, well, the problems we've got in society are so bad, it's because of the society, and so we need to undo society in order to improve it. Have a revolution, burn everything to the ground, start again. Well, this is entirely ludicrous. It's the wrong way of going about things. We don't know how to maintain stability, progress, moral, ethical, legal, and scientific progress without the kind of institutions that we have slowly and painfully managed to create, managed to evolve over time through difficult trial and error. Because the historical state of things, I wouldn't like to say the natural state of things. The natural state of things is us striving to improve things. But historically, the state of humanity has been tribal and violent and not making any progress, and everyone being just mired in poverty and disease. And if we did burn everything to the ground, that's what we should expect would come back again. It would be the hellscape. It would be the kind of thing that David is about to talk about that certain intellectuals think already is going to happen. It's not going to happen unless people deliberately try to undo the institutions and traditions that we have. And traditions are very, very important. I've heard some quite prominent and influential intellectuals that I respect on many other matters dismissing the importance and indeed the centrality of tradition within our culture, within Western culture. Tradition is just so important. The way in which we have done things hitherto, it's not to say that those traditions cannot be improved or should not be improved, but they should be only incrementally improved, slowly improved. Let's take away one part we don't particularly like, replace it with something that we think might be better, but let's be careful about it and be very reasonable in our criticism of whether or not that change has affected an improvement, an objective improvement or not. Because what we might find is many of these traditions that people might think are silly quirks of just historical accident might contain within them important inexplicit knowledge about how to ensure that everyone can coexist peacefully and continue to make the kind of progress and improvements that we have become accustomed to. That is indeed our tradition. Let's think of one. I'll give you one. The institution of marriage, the traditional institution of marriage. Some people want to undo it, or some people want to apply it to an entire spectrum of different relationships. This is very dangerous. The tradition of marriage has gradually evolved over time and improved over time slowly. Now, we might think that either doing away with the institution of marriage altogether might improve things, or allowing anyone to marry anything might improve things as well. Why not? Why not be free? Well, that would undermine what has traditionally been the institution of marriage. I'm not saying the institution of marriage needs to be kept in the same way that it has been for the last 1,000 years. But if we're going to tinker with something like that, we do it at our peril to some extent, and we need to be very carefully calibrate the changes that we make to marriage and have a look. After a few years, if we change this particular part of marriage, this way in which marriage works, let's see how it works. Let's reflect. Let's not keep changing marriage until such time as families and societies, communities begin to fall apart. And only then, in retrospect, do we look back and go, oh, perhaps we shouldn't have completely undone what we thought of as marriage. Maybe that was a bad turn. This is the sense in which certain kinds of traditions are important to preserve, even if we think that institution might have aspects which are prejudiced or discriminatory. Sure, we don't want to discriminate against people. We might want to change certain institutions, but let's do it slowly via an incremental evolutionary process rather than a completely revolutionary one which undoes what for so long the overwhelming majority of people have thought of as an important tradition. And that's just what? That's just illustrative. It's not meant to be Brett Hall's opinion on the way in which the institution of marriage needs to be kept in exactly the same way forevermore. Merely saying that the institution of marriage has worked in a certain way to a certain extent for a long time in order to enable, for example, families, which are an important unit within communities and then broader civilization, to ensure that children are, for example, raised well. It doesn't mean that they can't be raised better. Of course, children can be raised better. But doing away with certain institutions that have allowed society hitherto to raise children well as a relative term, should not be toyed with, should not be used as a political football in order to allow different sides who want to either maintain the status quo forevermore or to completely upend and revolutionize things. In some sense, we need this tension. My only point there is that traditions are important, even if we personally, individually, or even as a large group sometimes, can't see how. Even if we can't see how the institution is important, we need to think very carefully about undoing the institution. Just because we can find single problems with the institution doesn't mean the entire institution needs to be thrown in the bin, metaphorically speaking. Okay, let's go back to the book, and I just want to flag here that we're about to come to one of my favourite anecdotes in the book. I think I like to call it the parable of Europium, and it's a wonderful example of all the ways in which people who argue that resources are going to run out ignore the fact that it's not so much about particular resources running out as about knowledge being scarce. And at the same time, ignorance being this infinitely deep well from which people draw their ignorance and then conclude on the basis of their ignorance that therefore disaster is going to come. That disaster is going to strike because they're ignorant of all the ways in which that resource might not run out or might be easily replaced by something else. Okay, so let's go back to the book, and here David is about to talk about when he was at high school. And so I'll have some remarks about this, comparing it to present-day high school. Okay, and David writes, "In 1971, while I was still at school, I attended a lecture for high school students entitled Population, Resources, Environment. It was given by the population scientist Paul Ehrlich. I do not remember what I was expecting. I don't think I'd ever heard of the environment before, but nothing had prepared me for such a bravura display of raw pessimism." Just pausing there, and my reflection on that. I guess that David would be absolutely horrified with what goes on in schools now. No doubt he has some knowledge. No doubt people watching this have some knowledge. I have a little bit of inside knowledge. Today, children do not need visiting experts to scare them about how their futures are basically some apocalyptic hellscape. They don't need visiting experts because their teachers do that. And not now and again, it's basically daily or weekly. They're getting it from every corner. In geography class, they will talk about all the impacts on population, all the impacts on communities of pollution, and of all the ways in which resources are being depleted and are about to run out. In science class, they understand how carbon dioxide is heating up the planet and causing the melting of the polar ice caps. This is a huge part of the curriculum. For a rather esoteric part of science, it forms a vast amount, it consumes a vast amount of the science curriculum. It's looked at from all angles. And of course, there's the moral aspect there as well in science class. Even mathematics does not escape. Mathematics class in many places does indeed consist of the rates at which, for example, you might have a study of the rates at which the polar ice caps are melting, or the rate at which the temperature is increasing, or the rate at which there's deforestation going on. And of course, it's all couched in terms of this is the fault of people. Okay, this is the fault of human beings simply existing, and that previous generations have caused this damage, and it's going to be left to the children to try and fix the damage, but there's little hope of that because we don't talk about the solutions, of course. So it's just an anti-human, anti-technology, certainly anti-energy, anti-so-called waste, especially plastics, view of the world. So David got this once from a visiting scientist, and students today get something similar every day or every week from their teachers. Now and again, of course, they might have a guest come in to say how it's much worse than what they've been learning. I smile and smirk a little bit, but it is quite disgusting and terrible, to be honest. Then putting aside concerns about whether or not schools need to exist in their present form, it would be wonderful if there was just a little optimism somewhere or other. Even the traditional parts of schooling, even if you go to a religious school, you will still encounter this. And of course, we know that religions, like for example the Catholic Church, are pivoting. That's the modern word. Are pivoting towards a pessimistic view of humanity. Even an institution otherwise concerned with the sacredness and the uniqueness of human beings are beginning to talk about the evils of human beings. Okay, back to the book. Ehrlich starkly described to his young audience the living hell we would be inheriting. Half a dozen varieties of resource management catastrophe were just around the corner, and it was already too late to avoid some of them. People would be starving to death by the billion in 10 years, 20 at best. Raw materials were running out. The Vietnam War, then in progress, was a last-ditch struggle for the region's tin, rubber and petroleum. Notice how his biogeographical explanation blithely shrugged off the political disagreements that were in fact causing the conflict. The troubles of the day in American inner cities, rising crime, mental illness, all were a part of the same great catastrophe. Just pausing there. First, just notice that list. It could easily be drawn from the newspapers today. So this is back in 1971. All the problems with American inner cities. I mean, I never stop hearing about how terrible things are in Los Angeles, and this portends the end times, apparently. And of course, right now, we're supposedly in the midst of a mass extinction of a kind. The Holocene extinction, as it's called. All due to us. We are the murderers. We are genocidal, species-level genocidal, a virus of a kind. We just spread out across the planet, wiping out other species. This is seemingly what we are. And this is what is taught to students. They do learn about the current great extinction events, and caused by us. I mean, how evil can we be? We are just irredeemably evil on this view. Back to the book. All were linked by Ehrlich to overpopulation, pollution, and the reckless overuse of finite resources. We had created too many power stations and factories and mines and intensive farms, too much economic growth, far more than the planet could sustain, and worst of all, too many people, the ultimate source of all the other ills. In this respect, Ehrlich was following in the footsteps of Malthus, making the same error, setting predictions of one process against prophecies of another. Thus, he calculated that if the United States was to sustain even its 1971 standard of living, it would have to reduce its population by 3/4 to 50 million, which was, of course, impossible in the time available. The planet as a whole was overpopulated by a factor of 7, he said. Even Australia was nearing its maximum sustainable population, and so on. Pause there, my reflection. So I have an article inspired by this called Cosmological Economics, which I've kind of turned into a video, which you can find on my channel there, or the Cosmological Economics. You just Google that, and it typically comes up now under my name. And it's precisely about this. We have this fellow in Australia, the Paul Ehrlich of Australia, if you like. His name is Dick Smith. He runs a chain of electronic stores, and he's otherwise a reasonably good science popularizer, but like everyone else of our age almost, he's a terrible pessimist and a prophet, and he speaks in exactly these kind of terms, that Australia is overpopulated. If you've been to Australia, especially if you've flown in over the top of Australia, you will see that it is very hard to even spot a community, let alone the overpopulation. The place is barren. It is barren. It's largely a desert, although not entirely. Even the desert parts become green almost every year. We have rains out there in the desert. We were constantly being told we're in a drought. There were floods recently, by the way. It simply isn't the case that the Earth is overpopulated. These claims of overpopulation are typically relying on the assumption that no new knowledge will be created, and that the rate at which we are consuming resources will remain the same as the population increases. It's the same old Malthusian argument that population increases exponentially, resource consumption increases linearly. We're not going to find any new resources. We're not going to solve any new problems. We're just going to run out of the resources we have. We're going to begin to starve, so on, etc., etc. It's been said for centuries. It is tiresome for optimists, generation after generation after generation, to encounter these same people, to win the argument, but for no one to ever notice that the argument has been won many times before. This is my pessimist coming out. Even though Paul Ehrlich has gone, even though Dick Smith will go as well, even though Greta Thunberg and the people who inspired her or follow her will go, there will be more. There will be more that will come. And so the debate never seems to be won because it's a powerful argument and people have to learn the refutation of the argument as well. And so it is this arms race between the people who argue the resources are going to run out and can point to all these scientific ways in which it is clear the resource is going to run out, and the optimists coming along and say, we understand that argument, however it's flawed for reasons X, Y, Z. Namely, we're going to solve those problems. We're going to create the knowledge. We're going to find new resources. We're going to be able to sustain more people on the planet. We're going to be able to support more people on the planet at a higher standard of living than ever before. Try and explain what's going on throughout history. That's the story of history. And there's a reason why things get better. Because we continue to improve our lot, because we live in a culture of criticism where we literally do improve things. We do solve our problems. We aren't simply a product of our environment. We shape the environment around us. This is a complicated argument. I realize that. It's a subtle argument, and so it's seemingly going to be the case that we just have to keep defending this thesis again and again and again and explaining it. And hopefully at some point we achieve escape velocity and we leave behind the pessimists as a small minority of naysayers. At the moment, they're still in the ascendancy. They're still in the majority. They still control the culture, control the media, control politics to a great extent. But there's light because more and more people are coming on board, and it becomes just impossible to deny the reality of improving standards, improving technology, the fact that we were able to come up with a vaccine to what would have otherwise been a terrible global pandemic that killed far more people than what it had in a much shorter amount of time than it did. But our knowledge was able to solve that problem. And it will continue to solve problems at an ever faster rate into the future. We'll never run out of problems, and we'll never run out of resources. That's the optimistic part. The pessimistic part is we just have to keep on having the argument for a long time yet. Okay, let's go back to the book. David's talking about how he's sitting in school, listening to the visiting professor. And he writes, quote, "We had little basis for doubting what the professor was telling us about the field he was studying. Yet for some reason, our conversation afterwards was not that of a group of students who had just had their futures stolen. I do not know about the others, but I can remember when I stopped worrying. At the end of the lecture, a girl asked Ehrlich a question. I have forgotten the details, but it had the form, what if we solve one of the problems that Ehrlich had described within the next few years? Wouldn't that affect your conclusion? Ehrlich's reply was brisk. How could we possibly solve it? She did not know. And even if we did, how could that do more than briefly delay the catastrophe? And what would we do then? What a relief. Once I realized that Ehrlich's prophecies amounted to saying, if we stop solving problems, we are doomed, I no longer found them shocking. For how could it be otherwise? Quite possibly that girl went on to solve the very problem she asked about, and the one after it. At any rate, someone must have, because the catastrophe scheduled for 1991 has still not materialized, nor have any of the others that Ehrlich foretold. Pausing there, my reflection. So it looks as though David Deutsch, when he was in high school, was the first optimist in the sense that David Deutsch talks about optimism. Right there where he says, if we stop solving problems, we are doomed. He was no longer worried because how could it be otherwise? So he understood even then that we would just continue to solve problems so we don't have to worry, because if someone says, how can we possibly solve that? If they don't know, it doesn't matter. Someone will solve it. Someone's going to put their mind to that and they will come up with a solution. We don't want to not solve certain problems, especially at a civilization level, destroying problems. We're going to turn our minds to it. So don't worry. We're going to get through. David Deutsch understood that then. Back to the book. Ehrlich thought that he was investigating a planet's physical resources and predicting their rate of decline. In fact, he was prophesying the content of future knowledge, and by envisaging a future in which only the best knowledge of 1971 was deployed, he was implicitly assuming that only a small and rapidly dwindling set of problems would ever be solved again. Furthermore, by casting problems in terms of resource depletion and ignoring the human level explanation, he missed all the important determinants of what he was really trying to predict. Namely, did the relevant people and institutions have what it takes to solve problems? And, more broadly, what does it take to solve problems? Okay, so just pausing there, my reflection here. We've been at pains to point out throughout this series that resources in the general sense, in the broad sense, are not infinite. Of course, you pick any one resource like naturally occurring crude oil. It's going to be finite because the planet is finite. And as far as we know, there's no other oil out there in the universe, as far as we know. So particular resources are going to be finite. But the far more important factor is that our knowledge is the scarce resource that we need. Whether we know how to replace the oil once it's run out or once it's running out, that's the important thing. And how, for example, we might mitigate problems that oil creates along the way. Of course, oil solves more problems than it creates, far more problems. And the problems that it creates are far better problems to want to solve than the problem that the oil solved in the first place. Namely, keeping people warm, helping us to generate electricity, helping us to get from A to B faster than we ever have before. These are really, really important problems to solve. And along the way, oil creates a few little problems. It creates some pollution. And we can solve those problems of pollution. But simply turning off the supply of oil because we're concerned about the problems that it causes way worse problems than it solves. And forcing someone to replace oil before they're ready to, before it's cheap enough for them to do so, is likewise a recipe for increased suffering. So ultimately, for any one resource, of course, it might run out. But ultimately, the resources won't run out. It has to be the case into the future. We know this, that we can have something like a 3D printer where the ink is single atoms and you just assemble the atoms Lego-like into literally any device that you want. So you can create any resource you want. You can create any piece of technology that you can think of. Anything that you can program the 3D printer to build, it will build. In other words, this thing would be a universal constructor. It would be able to build anything, including building things that can build anything at all, the universal constructor. But of course, we're not there yet. In the meantime, we're going to have the prophets and the doomsayers and the naysayers and the pessimists all. We have to deal with them. We have to deal with trying to refute their claims that the catastrophe is looming. And so that brings us to my favourite, my favourite anecdote in the book. It's the one I use whenever anyone talks about this particular point, about the scarcity of particular resource, and I like to counter with the scarcity of knowledge versus the bottomless pit, really, that is our ignorance. I shouldn't say pit. It's just a well. It's a well of ignorance. It's an infinite well of ignorance. We have an infinite amount of ignorance, but some people like to draw from the well of ignorance and try and plead for slowing down progress so that we don't get ahead of ourselves lest we run out of some resource they think that they've found is about to run out. And that deep well of ignorance is an important well today if you're a university PhD student working in the natural sciences or the environmental sciences in particular. Identifying any old thing that a human civilization happens to be relying on right now, calculating how much of known reserves we have of that thing, the rate at which we're using it, and then, of course, concluding with a prediction about the horrors that are about to unfold when the disaster strikes, when we actually run out of this thing. So this is effectively refuted by what we're about to talk about here and what we might subtitle The Parable of Europium. So let's go to that now. And David writes, a few years later, a graduate student in the then new subject of environmental science explained to me that colour television was a sign of the imminent collapse of our consumer society. Why? Because, first of all, he said, it served no useful purpose. All the useful functions of television could be performed just as well in monochrome. Adding colour at several times the cost was merely conspicuous consumption. That term had been coined by the economist Thorstein Veblen in 1902, a couple of decades before even monochrome television was invented. It meant wanting new possessions in order to show off to the neighbours. That we had now reached the physical limit of conspicuous consumption could be proved, said my colleague, by analysing the resource constraints scientifically. The cathode ray tubes in colour televisions depended upon the element europium to make the red phosphors on the screen. Europium is one of the rarest elements on Earth. The planet's total known reserves were only enough to build a few 100 million more colour televisions. After that, it would be back to monochrome, but worse. Think what this would mean. From then on, there will be two kinds of people, those with colour televisions and those without. And the same would be true of everything else that was being consumed. It would be a world with permanent class distinction, in which the elites would hoard the last of the resources and live lives of gaudy display, while to sustain that illusory state through its final years, everyone else would be labouring on in drab resentment. And so it went on, nightmare built upon nightmare. Pause there, just my reflection quickly. Notice how this is de rigueur. It is so common today. It is just what intellectuals say, especially with the advent of any technology, but particularly AI. If AI comes along, there will be the haves, the people who can afford the AIs and who never need to work ever again, and those who can't afford the AIs and no longer have any jobs because the AIs have long since taken them. There will be two kinds of people in the world, the haves and the have-nots, the AI quadrillionaires and the people who are unemployed and destitute. Then also think of any medical technology. The favourite one that people refer to these days, of course, any longevity type medicine, any kind of technology that might come along and increase our lifespan by a significant amount. You know, let's say you have this pill that can cure all the ills, let's say, that might kill you within an additional 200 years. So anyone who can afford to buy this pill can live between 200 and 300 years. Well, we're going to have two sorts of people to begin with, aren't we? We're going to have the people who can afford this pill, which no doubt these evil pharmaceutical companies are going to charge people untold millions of dollars in order to get a hold of this pill so that they can live forever. And the other people, they won't. They won't be able to afford it at all, and they'll have to die early. In fact, the cost of medicine just might generally go up because the rich people who live forever are going to demand all the additional treatments and resources from medical facilities and so on and so forth. No one ever acknowledges the fact that whenever a new technology comes out, of course there is a transition period, a short, increasingly short transition period where, yes, only the very wealthy can afford it. Only the very wealthy can travel into space at the moment commercially. But eventually the price comes down. It used to be the case that the first automobiles could only be afforded by the most wealthy in the world. It used to be the case that only the most wealthy in the world could afford the most fashionable clothes, and so on and so forth. This has always been the case. The first computers, the first home computers were only owned by the most wealthy. But the costs come down. The cost will always come down. But you need to have this initial investment by the most wealthy people. It is good and right and in a certain sense heroic for the wealthy people to try out these new technologies first, to pay a premium for them, so that then the economies of scale kick in and everyone can eventually afford it. Look at mobile phones. Okay, let's go back to the book where, again, just to recap, David is talking about how Europium is about to run out, according to his colleague, this other student who's studying environmental science. And he writes of his colleague, I asked him how he knew that no new source of europium would be discovered. He asked how I knew that it would. And even if it were, what would we do then? I asked how he knew that colour cathode ray tubes could not be built without europium. He assured me that they could not. It was a miracle that there existed even one element with the necessary properties. After all, why should nature supply elements with properties to suit our convenience? I had to concede the point. There aren't that many elements, and each of them has only a few energy levels that could be used to emit light. No doubt they had all been assessed by physicists. If the bottom line was that there was no alternative to europium for making colour televisions, then there was no alternative. Yet something deeply puzzled me about that miracle of the red phosphor. If nature provides only one pair of suitable energy levels, why does it provide even one? I had not yet heard of the Finetuning Problem. It was new at the time. But this was puzzling for a similar reason. Transmitting accurate images in real time is a natural thing for people to want to do, like travelling fast. It would not have been puzzling if the laws of physics forbade it, just as they do forbid faster than light travel. For them to allow it, but only if one knew how, would be normal too. But for them, only just to allow it would be a fine-tuning coincidence. Why would the laws of physics draw the line so close to a point that happened to have significance for human technology? It would be as if the centre of the Earth had turned out to be within a few kilometres of the centre of the universe. It seemed to violate the principle of mediocrity. What made this even more puzzling was that, as with the real fine-tuning problem, my colleague was claiming that there were many such coincidences. His whole point was that the colour television problem was just one representative instance of a phenomenon that was happening simultaneously in many areas of technology. The ultimate limits were being reached. Just as we were using up the last stocks of the rarest of rare earth elements for the frivolous purpose of watching soap operas in colour, so everything that looked like progress was actually just an insane rush to exploit the last resources left on our planet. The 1970s were, he believed, a unique and terrible moment in history. He was right in one respect. No alternative red phosphor has been discovered to this day. Yet, as I write this chapter, I see before me a superbly coloured computer display that contains not one atom of europium. Its pixels are liquid crystal consisting entirely of common elements, and it does not require a cathode ray tube. Nor would it matter even if it did, for by now enough europium has been mined to supply every human being on Earth with a dozen europium-type screens, and the known reserves of the element comprise several times that amount. Even while my pessimistic colleague was dismissing colour television technology as useless and doomed, optimistic people were discovering new ways of achieving it and new uses for it, uses that he thought he had ruled out by considering for 5 minutes how well colour televisions could do the existing job of monochrome ones. But what stands out for me is not the failed prophecy and its underlying fallacy, nor relief that the nightmare never happened. It is the contrast between two different conceptions of what people are. In the pessimistic conception, they are wasters. They take precious resources and madly convert them into useless coloured pictures. This is true of static societies. Those statues really were what my colleague thought colour televisions are, which is why comparing our society with the old culture of Easter Island is exactly wrong. In the optimistic conception, the one that was unforeseeably vindicated by events, people are problem solvers, creators of the unsustainable solution, and hence also of the next problem. In the pessimistic conception, that distinctive ability of people is a disease for which sustainability is the cure. In the optimistic one, sustainability is the disease, and people are the cure. Pause there, my reflection. That is beautiful, wonderful, and needs to somehow permeate the zeitgeist. It really does. Of all the messages here, the countercultural message is that people are the solution or the cure. It is only people that will solve the problems of tomorrow. Only people. People are not the problem. Overpopulation is not the problem. It's insufficient numbers of people that's a problem, because people are the things that generate ideas. We need more ideas. We need creative people to come up with solutions to our most pressing problems. They're not causing them. At least they're not causing worse problems, okay? Every solution that a person finds is going to generate new problems, but those problems are better, more interesting, more fun. They enable us to explore a greater range of possibilities and to do away with the problems that cause us suffering. We need more people to cure the diseases that we're going to discover tomorrow, as well as the ones we already know of today. We need people to figure out new resources as other ones begin to be depleted. We need people to figure out new technologies so that we can communicate better, so we can travel faster, and so on and so forth. People are the solution. They provide the solutions. They're the only thing that provide the solutions. The problems, the worst problems, are those ones thrown at us by a hostile universe. It's the universe that's not really helping us out. We have to eke out our existence, as I continue to say. We are the ones just scratching the surface of a reality which is evermore, unexpectedly, throwing floods, fires, earthquakes, natural disasters, diseases, comets, cosmological events, etc. and so forth. Okay, so if we don't want to go the way of the dinosaur, and if we don't want indeed other species to go the way of the dinosaur, we'd better have more people working faster, not to sustain the way things are, not to try and ensure that resources don't become depleted or that pollution isn't created. These are inevitable problems. Problems are inevitable. But as we know, all the way back in chapter 1, these inevitable problems have solutions if we try to find them, if we put effort into finding them, and if we encourage people to find those solutions rather than having people fixate upon problems and all the ways in which we can slow down progress, because in this ridiculous pessimistic worldview, it is faster and faster progress that leads us closer and closer to the end times. And that's precisely the wrong way to think about it. End times become closer and closer the more we slow down, the more we try and ensure that what we do is sustainable in the environmental sense. We need fast progress and error correction. We need knowledge creation. We need more people. Okay, back to the book. Just reading the last bit there. David said, quote, "In the optimistic one, sustainability is the disease and people are the cure. Since then, whole new industries have come into existence to harness great waves of innovation, and in many of those, from medical imaging to video games to desktop publishing to nature documentaries like Attenborough's, colour television proved to be very useful after all. And far from there being a permanent class distinction between monochrome and colour television users, the monochrome technology is now practically extinct, as are cathode ray televisions. Colour displays are now so cheap that they are being given away with magazines as advertising gimmicks. And all those technologies, far from being divisive, are inherently egalitarian, sweeping away many formerly entrenched barriers to people's access to information, opinion, art and education." Just pause there and just a little comment on that. Colour televisions are becoming so inexpensive, and the associated technology so inexpensive, audio systems, huge flat screen televisions, that going to the cinema is becoming redundant. Who would have thought of that? I mean, you can have a cinema experience inside your house. You can exceed what a cinema can do in many, many cases. So you can have your own projector and your own sound system in the comfort of your own home for a fraction of the cost overall as to what frequently going to the cinema would have been in days gone by. And yet, this is not undermining the movie industry, or at least the audio-visual industry. There is a renaissance of a kind with television. All of the ways in which people who we thought were going to lose their jobs because people weren't going to the movies anymore have more jobs than ever. All the people who are actors and who work on sound and vision and whatever else, they now have many new avenues on many different streaming services that are making movies and television shows of higher quality than ever before. The art is improving because the technology is improving and becoming cheaper, and all boats are rising with that tide. Let's keep going. David writes, "Optimistic proponents of Malthusian arguments are often, rightly, keen to stress that all evils are due to lack of knowledge and that problems are soluble. Prophecies of disaster, such as the ones I have described, do illustrate the fact that the prophetic mode of thinking, no matter how plausible it seems prospectively, is fallacious and inherently biased. However, to expect that problems will always be solved in time to avert disasters would be the same fallacy, and indeed the deeper and more dangerous mistake made by Malthusians is that they claim to have a way of averting resource allocation disasters, namely sustainability. Thus they also deny that other great truth that I have suggested that we engrave in stone: problems are inevitable." Just pausing there, just my reflection on this. Now, having heard David be interviewed many times over the years now about the beginning of infinity, one of the common misunderstandings that people seem to have on this point is the idea that problems are soluble, which is true, problems are soluble, that this somehow means it is inevitable that the problems will be solved and that progress is inevitable. This is not what's being claimed, and David has never said this, but it is a very common misunderstanding of this entire thesis. We have to work hard to solve problems. And because problems are inevitable, that undermines this thesis that therefore progress is inevitable. No, there will be problems coming along. And if we don't choose to work really hard to try and solve these problems, then progress will falter. It will stop. We can go the way of the dinosaur. There's nothing in this worldview of David Deutsch that says we cannot go extinct. He can't say whether we will go extinct or not. No one can say we will go extinct or not. But he's saying there's a possibility that we won't go extinct. We could be the first. It is certain, as certain as anything can be, that, well, given our current knowledge, we can predict that absent us, absent human beings, every species that exists on this planet will go extinct. Absolutely. Absolutely. We know, okay, if it's not going to be the sun expanding into a red giant and evaporating all the oceans and consuming the Earth in a massive fireball, then other asteroids will hit, other comets will hit, a supernova will go off nearby, a massive volcano will go off, something will happen that will wipe out all life on Earth. It is going to happen. But the fact that we're here means that there's a chance that not only will that not happen, but that we will be the ones who are able to survive. Maybe we'll leave the Earth behind, maybe. But we can survive if we choose to create knowledge and if we choose to solve the problems in time. But there's no guarantee of that at all. David has been at pains to say that there's no guarantee of this. It's just that we have the chance of doing so, a chance that no other species hitherto has ever had. We are the one possible exception to the rule. So we need to emphasize that. Problems are soluble, but it's not inevitable that they will be solved. It's only inevitable that they will arise, and that if we want to, we can try and solve them. Okay, back to the book. And he writes on this point, a solution may be problem-free for a period and in a parochial application, but there is no way of identifying in advance which problems will have a solution. Hence there is no way, short of stasis, to avoid unforeseen problems arising from new solutions. But stasis itself is unsustainable, as witness every static society in history. Malthus could not have known that the obscure element uranium, which had just been discovered, would eventually become relevant to the survival of civilization, just as my colleague could not have known that, within his lifetime, colour televisions would be saving lives every day. So there is no resource management strategy that can prevent disasters, just as there is no political system that provides only good leaders and good policies, nor a scientific method that provides only true theories. But there are ideas that reliably cause disasters, and one of them is, notoriously, the idea that the future can be scientifically planned. The only rational policy in all three cases is to judge institutions, plans, and ways of life according to how good they are at correcting mistakes, removing bad policies and leaders, superseding bad explanations, and recovering from disasters. Okay, now I'm skipping a bit in this chapter, and David talks about how for a whole bunch of solutions, there's always been the naysayers. So antibiotics, someone will say, oh, this is only temporary antibiotics which kill bacteria. Just you wait until the antibiotic-resistant pathogens come along, then we'll be in trouble. And so people like to talk about how all we're ever doing is postponing disaster. For every solution, just you wait, something will come along for which we will have no solution. And so I'm skipping that. Let's just go to where he talks briefly about climate change, where he says, quote, we face the prospect that carbon dioxide emissions from technology will cause an increase in the average temperature of the atmosphere, with harmful effects such as droughts, sea level rises, disruption to agriculture, and the extinctions of some species. These are forecast to outweigh the beneficial effects, such as an increase in crop yields, a general boost to plant life, and a reduction in the number of people dying of hypothermia in winter. Trillions of dollars and a great deal of legislation and institutional change intended to reduce those emissions currently hang on the outcomes of simulations of the planet's climate by the most powerful supercomputers, and on projections by economists about what those computations imply about the economy in the next century. In light of the above discussion, we should notice several things about the controversy and about the underlying problem. First, we have been lucky so far. Regardless of how accurate the prevailing climate models are, it is uncontroversial from the laws of physics, without any need for supercomputers or sophisticated modelling, that such emissions must eventually increase the temperature, which must eventually be harmful. Consider, therefore, what if the relevant parameters had just been slightly different, and the moment of disaster had been in, say, 1902, Veblen's time, when carbon dioxide emissions were already orders of magnitude above their pre-Enlightenment values. Then the disaster would have happened before anyone could have predicted it or known what was happening. Sea levels would have risen, agriculture would have been disrupted, millions would have begun to die, with worse to come, and the great issue of the day would have been not how to prevent it, but what could be done about it. They had no supercomputers then. Because of Babbage's failures and the scientific community's misjudgments, and perhaps most importantly their lack of wealth, they lacked the vital technology of automated computing altogether. Mechanical calculators and roomfuls of clerks would have been insufficient, but much worse. They had almost no atmospheric physicists. In fact, the total number of physicists of all kinds was a small fraction of the number who today work on climate change alone. From society's standpoint of view, physicists were a luxury in 1902, like colour televisions were in the 1970s. Yet to recover from the disaster, society would have needed more scientific knowledge and better technology and more of it. That is to say, more wealth. For instance, in 1900, building a seawall to protect the coast of a low-lying island would have required resources so enormous that the only islands that could have afforded it would have been those with either large concentrations of cheap labour or exceptional wealth, as in the Netherlands, much of whose population already lived below sea level thanks to the technology of dike building. This is a challenge that is highly susceptible to automation, but people were in no position to address it in that way. All relevant machines were underpowered, unreliable, expensive, and impossible to produce in large numbers. An enormous effort to construct a Panama Canal had just failed, with the loss of thousands of lives and vast amounts of money due to inadequate technology and scientific knowledge. And to compound those problems, the world as a whole had very little wealth by today's standards. Today, a coastal defence project would be well within the capabilities of almost any coastal nation and would add decades to the time available to find other solutions to rising sea levels. If none are found, what would we do then? That is a question of a wholly different kind, which brings me to my second observation on the climate change controversy. It is that while the supercomputer simulations make conditional predictions, the economic forecasts make almost pure prophecies, for we can expect the future of human responses to climate to depend heavily on how successful people are at creating new knowledge to address the problems that arise. So comparing predictions with prophecies is going to lead to that same old mistake. Just pausing there, just my reflection, we really need to emphasize this. So there are scientific predictions of what is going to happen with climate change, scientific predictions, derivations from good explanations, using supercomputer modelling. Of course, there's going to be errors with these, and yes, they change now and again, but this does not change the fact that there really is a scientific theory about how, for example, certain gases, like carbon dioxide, like methane, really do interact with certain kinds of light. So, for example, the bonds in the carbon dioxide molecule just happen to be right to resonate with certain photons of light, and then they re-emit that light in all directions, including towards the ground, as infrared radiation. And so we know the mechanisms that cause climate change. It really is a real thing, and you really can make reasonable predictions about these things. All that aside, putting all of that aside, knowing that climate change is a real phenomenon, and it really is affected by the burning of fossil fuels, for example. Those predictions are in a completely different category to what will happen economically as a consequence of that possible natural disaster. What would be a natural disaster if we didn't do anything about it. But we will do something about it. As it becomes more clear to politicians, industry leaders, and so on and so forth, things will be done. Things are being done already. But trying to suggest that this is going to mean economic tragedy, that it's going to require certain economic tweaks and changes to the economy, is all based upon not scientific prediction, but upon pure guesswork, pessimistic guesswork about the future ways in which people will trade one with another. But this is to do with their free choices and what knowledge they'll create. So let's go back to the book, and David writes, again, suppose that disaster had already been underway in 1902. Consider what it would have taken for scientists to forecast, say, carbon dioxide emissions for the 20th century, on the shaky assumption that energy use would continue to increase by roughly the same exponential factor as before. They could have estimated the resulting increase in emissions. But that estimate would not have included the effects of nuclear power. It could not have, because radioactivity itself had only just been discovered and will not be harnessed for power until the middle of the century. But suppose that somehow they had been able to foresee that. Then they might have modified their carbon dioxide forecast and concluded that emissions could easily be restored to below the 1902 level by the end of the century. But again, that would only be because they could not possibly foresee the campaign against nuclear power, which would put a stop to its expansion, ironically on environmental grounds, before it ever became a significant factor in reducing emissions, and so on. Time and again, The unpredictable factor of new human ideas, both good and bad, would make the scientific prediction useless. The same is bound to be true, even more so, of forecasts today for the coming century, which brings me to my third observation about the current controversy. It is not yet accurately known how sensitive the atmosphere's temperature is to the concentration of carbon dioxide. That is, how much a given increase in concentration increases the temperature. This number is important politically because it affects how urgent the problem is. High sensitivity means high urgency. Low sensitivity means the opposite. Unfortunately, this has led to the political debate being dominated by the side issue of how anthropogenic, human-caused, the increase in the temperature to date has been. It is as if people were arguing about how best to prepare for the next hurricane, while all agreeing that only the hurricanes one should prepare for are the human-induced ones. All sides seem to assume that if it turns out that a random fluctuation in the temperature is about to raise sea levels, disrupt agriculture, wipe out species and so on, our best plan would simply be to grin and bear it. Or if 2/3 of the increase is anthropogenic, we should not mitigate the effects of the other third. Trying to predict what our net effect on the environment will be for the next century, and then subordinating all policy decisions to optimizing that prediction cannot work. We cannot know how much to reduce emissions by, nor how much effect that will have, because we cannot know the future discoveries that will make some of our present actions seem wise, some counterproductive, and some irrelevant, nor how much our efforts are going to be assisted or impeded by sheer luck. Tactics to delay the onset of foreseeable problems may help, but they cannot replace, and must be subordinate to, increasing our ability to intervene after events turn out as we did not foresee. If that does not happen in regard to carbon dioxide-induced warming, it will happen with something else. Indeed, we did not foresee the global warming disaster. I call it a disaster because the prevailing theory is that our best option is to prevent carbon dioxide emissions by spending vast sums and enforcing severe worldwide restrictions on behaviour, and that is already a disaster by any reasonable measure. I call it unforeseen because we now realise that it was already underway even in 1971 when I attended that lecture. Ehrlich did tell us that agriculture was soon going to be devastated by rapid climate change, but the change in question was going to be global cooling caused by smog and the condensation trails of supersonic aircraft. The possibility of warming caused by gas emissions had already been mooted by some scientists, but Ehrlich did not consider it worth mentioning. He told us that the evidence was that a general cooling trend had already begun and that it would continue with catastrophic effects, though it would be reversed in the very long term because of heat pollution from industry, an effect that is currently at least 100 times smaller than the global warming that preoccupies us. Pause there, my reflection. A planet like Earth, geologically speaking, is active. It's geologically active. It's kind of alive in a geological sense. The outgassing of volcanoes coupled with rain, which absorbs those gases in the atmosphere and then causes the acidification of oceans, which can then cause precipitates to form at the bottom of those oceans, which are then carried into the core of the Earth and then re-erupted back into the atmosphere by those same volcanoes. This process, this constant process, this carbon cycle, this natural carbon dioxide cycle, coupled with the way in which we orbit the planet, would mean that even if there was no anthropogenic climate change, there would nonetheless be climate change. It would be absolutely astonishing if the climate did not change, if there wasn't a trend of heating or cooling. So regardless of whether humans are doing it or not, regardless of that, let's say we find that there is climate change, but humans aren't doing anything at all to contribute to it. Okay, that's not the case at the moment. Okay, but let's say that it was. Let's say that scientists come to a consensus tomorrow and the United Nations begin to tell us about how, hey, guess what, everyone, the fossil fuel thing isn't what we thought it was. There's no human-induced climate change. There would still be climate change. Okay, there would be climate change via other factors. And that climate change will eventually cause problems for humans. It'll either cause the sea levels to rise, or it will cause the amount of ice to increase. It'll cause the temperature to change in uncomfortable ways for people living in certain places. And we should want to mitigate that. We should want to treat the planet like we treat our homes. Sometimes they're too cold, sometimes they're too warm. We should want to, regardless of whether humans are causing the climate change or not, want to control the climate. And even if the almost impossible was to happen and nothing ever changed on planet Earth with respect to the climate, we should still want to change the climate. We should still want to make the places that are barren fertile. We should still want to change the certain places in the poles which are too cold to be somewhat warmer. If we can do that, we should. This whole idea of living in a pristine natural environment, well, we've countered that. We don't like that. The natural environment is not a good thing, even for the species that sort of evolve there, because the environment is hostile in very many ways. Okay, so let's go back to the book. And David's about to write what he says in one of his TED Talks. Quote, he says, "There is a saying that an ounce of prevention equals a pound of cure, but that is only when one knows what to prevent. No precautions can avoid problems that we do not yet foresee. To prepare for those, there is nothing we can do but increase our ability to put things right if they go wrong. Trying to rely on the sheer good luck of avoiding bad outcomes indefinitely would simply guarantee that we would eventually fail without the means of recovering. The world is currently buzzing with plans to force reductions in gas emissions at almost any cost. But it ought to be buzzing much more with plans to reduce the temperature or for how to thrive at a higher temperature, and not at all costs, but efficiently and cheaply. Some such plans exist, for instance, to remove carbon dioxide from the atmosphere by a variety of methods, and to generate clouds over the oceans to reflect sunlight, and to encourage aquatic organisms to absorb more carbon dioxide. But at the moment, these are very minor research efforts. Neither supercomputers, nor international treaties, nor vast sums are devoted to them. They are not central to the human effort to face this problem, or problems like it. This is dangerous. There is as yet no serious sign of retreat into a sustainable lifestyle, which would really mean achieving only the semblance of sustainability. But even the aspiration is dangerous. For what would we be aspiring to? To forcing the future world into our image, endlessly reproducing our lifestyle, our misconceptions and our mistakes? For what would we be aspiring to? To forcing the future world into our image, endlessly reproducing our lifestyle, our misconceptions and our mistakes. But if we choose instead to embark on an open-ended journey of creation and exploration whose every step is unsustainable until it is redeemed by the next, if this becomes the prevailing ethic and aspiration of our society, then the ascent of man, the beginning of infinity, will have become, if not secure, then at least sustainable." The end of the chapter. There we go. A wonderful way to end it. The sustainability that we want, the sustainability we want and need and require in order to survive is constant change, is this open-ended journey of creation and exploration. Each step of which is unsustainable. You can't stay there at that step just doing that same thing over and over again. It's not sustainable. What is sustainable is change, this rapid progress, this journey of creation and exploration. And so we come, finally, to chapter 18, to the conclusion of the book, which I think will take some weeks to get through. There will be many episodes based on the beginning, which is chapter 18. And it's appropriate that it's called the beginning, because this is, as I have said before, the beginning of infinity, the beginning of spreading these ideas, of finding new ways in which to promote the understandings and the learnings that are within this book, the messages that are in this book, because this is civilization level important, as we've just learned from that previous chapter. We need to counter the prevailing narratives about all of these topics. And it's simply a good way. The book is a good way of having a touchstone, a way of summarizing what this worldview is. The worldview is clearly summarized and encapsulated within the book, but it's beyond the book, of course. And there's many more people and communities that need to spring up and have an optimistic view of humanity and problem solving. But for now, until next time, bye-bye. Just a thank you to my Patreons, and if you'd like to become a Patreon of mine, I would greatly appreciate it. You can find me at patreon.com/Talkcast, or simply Google Talkcast Patreon, or even Brett Hall Patreon, and something will come up there for you. Or you can go to my own website, www.bretthall.com, unsustainable.org, and you'll find a link there to a PayPal link. And so you can donate. There's a donate button there. And it is greatly welcome, greatly appreciated. Any contributions that anyone can make at whatever level. Thank you so much. Until next time, bye-bye.